Okay, so let's start section 4.6, the applied optimization. Okay, and these types of problems always give you a short paragraph and then with some information ask you to read the problems and then abstract the information, build one equation or function, and then solve that, right? So the problem could be, under a limited budget, how can you make the maximum profit for a given company? Okay, or if you have a limited materials, ask you to build, let's say, a fence or I don't know, a box, and how do you cut so that the fence can form the largest area or the box can get its largest volume, such kind of problems. Okay, and you know, so those type of problems, if it's the first time you see this, I would like you to follow those five basic steps and then keep practicing because practice makes perfect. Really, I remember when I first started to work on those optimization problems in college, and it gave me a hard time, to adjust this type of questions. Okay, and now let's look at those five steps. Okay, so step one, you see, read, read, and read. Okay, and often a lot of students skip this part, and then they read the problem fairly quickly, and then have you know some ideas may not be very clear ideas, and then starting to do the problems. Okay, this actually is not a very good start. Okay, when we handle this type of questions. Normally, if I let's see, if I want to solve one applied problems, let's say in 15 minutes, um, I often will take at least 3 minutes, to read the problem. Okay, and so please read the problem carefully, very carefully, and then there are a lot of info uh, in the paragraph, and then you have to get them out. Okay, and the second thing is, if possible, uh, please draw a picture. Okay, for example, if I ask you to form a um, like a square or a rectangular area, you better to draw them, and then if the some information is given in that problem, you can fill in that pieces. Okay, so anytime if you can draw a picture, that's gonna be very very helpful. Okay, and after that we starting to think, read the problem very well, and then we draw the picture, and then we're starting to find, okay, what is the unknown variable? Okay, in other words, there's something I don't know the problem want me to figure out. For example, the problem could be, okay, give you a limited materials, and then um, how do you organize such that the square, excuse me, the rectangular can have its uh, maximum area. Okay, so you can see that if the total length of the materials is given, and then we form the rectangulars, we don't know the dimension, right? And then if we set, let's see, the height, or excuse me, the length, um, of the side of the rectangular is x, then the length of the adjacent side we can easily calculate because the total length we already know that. Okay, so first step is trying to figure out here what is unknown. Okay, what is unknown? And the step 4, once you set up one variable as an unknown, for example, set the unknown length as x, and then step 4, we're trying to construct a function with our unknown variable. For example, if you try to figure out the area of that rectangular, we know that the area equals the width, right, times the height, and then we can construct our area function. And then often the problem will ask you, okay, how to do so that the area can be maximized, and then you see that this actually related to section 4.1 when we talk about the extreme values, right? We are actually looking for the absolute max. So find the critical point, and then also evaluate it at the critical point and also the end point to do a comparison, and then get a conclusion, which is the extreme values. Okay, so those 5 steps. Read the problems and then draw a picture if you can.